Hello everyone. So let us continue our discussion in module 6. So today we will be uh, discussing the information dealing with relationships between various components. So links, as you know, links are relationship between components. These components can be either people or it can be various equipments or things. So links show the relationship between these components. And this can be classified as communication links, which are functional, control links, which again come under the functional category, and then third one is movement links, which are sequential, or the movement of various things sequence one after the other. Now under communication links we can think of visual, auditory, it can be voice or non-voice, and touch. All these comes under communication links. And control links, various measures to control the various activities that is performed in an environment. And the movement links, it can be eye movements, manual movements, foot movements, or both, and then overall our body movements. These all comes under movement links. Now, how to summarize various link data? That is, link data is often summarized in a table as shown in this figure. This is called the link table. An example of a link table is shown in figure for its component in a hypothetical mini computer laboratory. In this example, each relationship of the component with any other was rated using the following scale. That is, we use a scale to categorize or to summarize the link data. We uses the alphabets, or rather vowels, A, E, I, O, U, and then finally one more thing, one more alphabet, that is X. So A is for absolutely essential things or essential activities, which that means it has to be located very close. And the second vowel, that is E, it is for essential for two activities to be located close together. So the third one, I, is important activities that has to be located together, and O is for ordinary closenesses for two activities to be considered, and U is a link does not exist, and it is unimportant whether two activities are placed together. So you can see that all these as the importance is being gradually reduced as you go from A to X. So A is, once again, A is absolutely an essential activity, E is essential activity, I is important activity, O is ordinary activity, and U is an unimportant whether they are placed together, and X is highly undesirable activity. That means the two cannot be placed together. Now if you see this figure, you have different components, that is computer 1, computer 2, and then a tape, disk 2, etc. And you have a relationship or link data as shown in this figure. So if you are going to highlight these first three categories, that is 1, 2, 3, that is here. As you can see, what is written here is this cell corresponds to the relation between 1 and 3. 1 and 3. Okay, this much area refers to, this is related to 1 and this is related to 2. So the overlapping area, this cell belongs to 1 and 3. And below that shows the importance of the relationship, and reasons for that it is given in the code. And the code is separately highlighted here, like one is for similar service required, or what are the reasons that has to be written is given here. So in short, this is a way of summarizing the link data, or it is how you represent the various relationship between different components in an activity. So link table is one of the method of summarizing the data, and another one is a graphic representation of link data. So the here we are discussing about two types of link diagrams. One is adjacency layout diagram and a spatial operational sequence or SOS diagrams. These are the two important things that we'll be looking in this session. So the first method is adjacency layout diagram. So a figure of adjacency layout diagram of the eye movement between various instruments in an aircraft during a maneuver is shown in figure. And here the problem is it doesn't show the sequence in which components are used. Only what you can make out from this figure is the thicker the line, the more frequent or how frequent it is being used, that you can make out from the thickness of the each lines. So this figure shows the movements between aircraft instruments during a specific maneuver. As I have already mentioned, thicker the thickness of the connecting line is used to code the frequency. Thicker the line, more frequent or more important the link is. The drawback is does not indicate the sequence in which components are used. So from this figure, you can see that there's a instrument, the different, the pilot looking at different points, that is cross pointer, airspeed, directional gyrometer, and etc. These are different areas where the eye movement of a pilot is being represented. So the next method of representing graphic data or graphical representation of data is spatial operational sequence, or commonly known as SOS diagram. So here we overcome the disadvantage of the previous method. That is, here we can actually tell the sequence in which each operation is being done, and this is overlaid in a pictorial representation in the workspace. And the figure here shows an operator who is tracking an aircraft on a cathode ray tube. And the numbers in each of these figure numbers in this representation depict the sequence of the steps which are taken. So obviously SOS diagrams are most useful when a set of sequence operations are performed with components. And now we come to the next topic, that is arranging components by using linked data. The first one, of course, is the trial and error method. Designer physically arranges scale drawings of the components, trying to maximize criteria that often conflict with one another. And in the same way, he will try to keep the most frequently used components in the advantageous positions or locations, and arrange components to minimize the length of frequent or important links, and keeping in mind the sequence of the operations of the function grouping. So obviously this is the trial and error method. And the next one is linear programming. We will not be discussing linear programming in detail, but it is useful for complex systems, and that means when you have many components, many permutations and combinations, then you will go for linear programming. So here the method is based on optimizing some criteria, or getting some dependent variable and manipulation of various independent variables. The optimum means it can be minimum value in certain cases and the maximum value in certain other cases. So depending upon the situation, it can differ. So that is about linear programming.